Thanks again for the invitation. So in the next few minutes, we'll go through a toolkit. These are my disclosures. I prefer to sort of look at it as a team approach, so each position is important. So I think you got to start with some sturdy folks at the back if you want to succeed. So that would be vascular access and sheaths. Obviously, there's a myriad of ways to go about things, antegrade or retrograde. There's guide sheaths. They come in various lengths, 5 French, there's 4 French, obviously, in the works, and then there's very specific pedal access sheaths that can be very useful, or you can also use coronary radial equipment very effectively. In terms of crossing catheters, support catheters are very useful below the knee. Again, you've got a variety of 014 and 018 choices, and you also can fall back on coronary CTO equipment if needed, and we'll find that very useful. In terms of reentry catheters, we saw a little bit of that earlier today. Obviously, the larger catheters like the Outback, Pioneer, and Off-Road are for popliteal segments. The anterior can be useful in the tibial vessels if needed. And then basically all the atherectomy devices are available for use in the popliteal and below the knee segments, just depending on the plaque morphology and what you want to achieve with your atherectomy. So now moving into what I believe is probably the most important position, and that's wires, because if you can't get your wire where you need it, then you're not going to succeed. So there's a variety of wires. I always think that it's very useful when you're choosing wires to understand how they're made and what their characteristics are, and choose what you need from the wire. Do you need weight? Do you need stiffness? Or do you need lubricity to cross? Do you need it to retain its shape? Are you planning on doing multiple vessels? Would you like it to be safe if it prolapses and has to be pushed through? So these are things that are very important to understand in terms of the wire technology and how it's constructed. There's different components, obviously, the tip and the core. There's various coverings, and they have advantages and disadvantages. And when it comes to core material, you'll find mainly stainless steel and nitinol. And again, you have to think about what you're trying to achieve in terms of the wire, whether you need mainly support or mainly crossing and kink resistance. And then also remember that the diameter difference is not 1 + 1 = 2. So when you go from an 014 system to an 018, there is a significant increase in strength. And so I think that's also important in terms of what you're trying to achieve. In terms of the tips, you need to understand, are you trying to get through a CTO or a shorter taper that'll buckle quickly and with a support catheter cross be more useful, or are you going to need a longer taper to where you cross the lesion and then get into one or other of the branches below the knee? And then also the last wire characteristic is the covering. So lubricious wires are great. They go all sorts of places. The problem is you trade that for tactile feedback, because sometimes they go to places you don't necessarily want or aren't necessarily going to be helpful. So I think if you understand the basic construct of the wires, you can choose your wires specifically for what you're trying to achieve. This is the basic algorithm where you wire escalate. So if it's a workhorse situation, you try your workhorse wire. If it doesn't work, based on different characteristics, you just pick another wire and proceed until you can cross the lesion and deliver. So finally, the final set of catheters obviously are balloons. And I also think, it's interesting to understand how the balloons are constructed, particularly how they're folded, because slow, long inflations tend to work really well below the knee. So being in a hurry and not understanding that these trifold balloons can just pop open and damage the artery, I think is important. I think you also need to understand where the support is coming from and the tip in terms of the crossing profile. And that's evidenced here. So how does it track? How are you able to push? That sort of support, I think, is very important. And that's basically, if you know how the balloon is made, you'll understand these characteristics. You also should understand the compliance, right? So more compliance means more growth, but it's also more flexible and can travel better. But the compliance curves here demonstrate the point where if you go with a non-compliant balloon, you can go very high on atmospheres without experiencing the growth, but you will give up some trackability as a trade-off. Specialty balloons, I'm not going to get into all of them, but essentially the concept is that they engage the lesion so that you don't have a lot of slippage, and then Some of these balloons, most of these balloons are made to sort of put the force across the lesion evenly, again, to hopefully minimize damage. And then finally, I think if you're going to do any of this stuff and you're going to need to get tibial access, the hockey stick ultrasound probe is going to be very useful. And so with that, I'll end. This is putting it all together. It's taken a crossing catheter through a long sheath. You take an 018 wire and a support catheter, and sometimes you need all of that to succeed. So these things can be painful, but you just have to go for it sometimes. Thank you very much.